Hi, today we're going to talk about how we can prove the Pythagorean theorem. Anytime something is a theorem, it means it can be proven. And there are hundreds, if not thousands, of proofs in the world for solving or proving the Pythagorean theorem. One of them, which is kind of cool, is if I make a 3, 4, 5 triangle, and notice that this side is 3 units, 1, 2, 3, and this side is 4 units, and this side is 5 units. You'll notice that if I make a square out of the 3 times 3, I have 9 squares. If I make a square next to the 4, you'll notice that I have 16 squares. So 4 squared is 16, 3 squared is 9. 5 squared is 25. And if you count, you'll realize that I have 9 pink squares from the 9. And I have 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you can see that my 9 pink squares and my 16 green squares fit in here. So this is one proof. Another proof, we can use another what we call Pythagorean triple. Let me make this a little smaller for you. And this is called a 5, 12, 13 triangle. And it turns out that if I have 5, this is a 5 by 5 square with 25 squares. This is a 12 by 12 square. And this is a 13 by 13 square. And just to make it simpler, you can see that if I have 12 by 12, then this would be 12 yellows plus that box, and then 12 yellows. 12 plus 1 is 12 is 25. So this is another proof, another way of showing that 5 squared plus 12 squared is equal to 13 squared. Another method, and that was kind of the same method only with a different square. And this one's a little bit complicated, but we'll do this one together too. And this one is one of the ones that the book likes to show you. And if I have, notice here I have a right triangle, where one side is A, the leg is B, and then a hypotenuse. If you notice, this is the exact same triangle, and this is the exact same triangle, and the exact same triangle. So notice that on the inside, I have a square. This is a square, every side is C. And so what I did is I actually cut out these triangles that were all identical, and I replaced them so that these 4 triangles are here such that what is left is I have a square that is A squared and a square that is B squared. Because my total area of the large square is the same, I know that this blank area and this blank area have to be the same. What we're going to do right now is I'm going to ask that you get, if you have access to some colored paper and another piece of paper and scissors. I'm going to ask you to go get some right now and pause the video, and we're going to prove it ourselves. All right, well, welcome back. What I want you to do with your paper, and again pause and rewind as necessary, is I took a colored piece of paper, although it doesn't have to be colored, and I carefully folded it in 4s, trying to keep the corner pretty close. Because what I'm going to do is I'm going to make 4 right triangles, and I'd love for you to do this too. And I am going to very carefully cut cut across there as straight as I can to make a right triangle, trusting that this is already a right angle. So I'm going to just kind of randomly cut here, trying to cut straight. Maybe not the straightest in the world, but let me try that again. So Is it fairly straight? Probably could be better, but close enough. All right. Now what I'm going to do is, on my plain piece of paper, I am going to make that same diagram with those 4 triangles. Well, first of all, like this. Sorry. Let me make this smaller for you so you can see. I'm going to make a square with my 4 triangles. And again, all of these 4 right triangles are identical. And just to show that they're the same area, I am going to trace them with a highlighter. Trace this side with a highlighter. Trace this side with the highlighter. Trace this side with the highlighter. And finally my last side. So I know that what I have here is I have a square in the middle. You can see that. That's my c squared. Does that look more like a square? And I'm now going to re-put these this. So I know that the empty area is the same in both. So I know that this was A, this was B, this was A, this was B, this was A, B, A, and B. These are all my right angles. Remember, the legs form the right angles. So what I have in this square right here, this has a square of A times A, so this is A squared. And this was B times B, so that's B squared. So this is a way to prove that A squared plus B squared equals C squared.